Yeah, in the last class, we were talking about inner functions and we had discussed about that inner functions. And today we need to start with another very useful topic in Python, lambda functions or anonymous functions. Okay, we'll do one by one. And before that, there is one more quick thing we need to check. We are done with this inner functions. We had very clear discussion on the previous class. So just a minute. So this is fine. Yeah, this is one small example we need to discuss. Okay, fine. We can even discuss after lambda functions as well. Everything should be fine. So we'll start with lambda and then we come back to this example as well. This is also one more useful example for us. So we have included this example to our discussion. So this is an example where we can pass a function as a parameter to another function. This is a very simple example. It's not too difficult to understand, but similar examples we can see in a lot of existing code or in development. So this is one thing really useful for us, friends. Okay. Anyhow, as we have already here, let's quickly discuss this and jump to lambda functions. So you can see here we have defined this nested function, and this is a very simple function. We don't have really something difficult to understand. So we have an outer function and we have an inner function, and this is just returning so square of this x. That's all. Right. So x square here you can see here. So this inner function just when you pass x to that inner, it just squares that and then returns that. Okay. So now return, and here what it does is it returns the inner function. So that is what this is doing, friends. Yeah. So we had discussed how to return inner function from outer function in the last class, and that example should be very clear for you, friends. So, so this outer function is returning inner function as a value, and what we should do here. So wherever we are calling outer function, there we should assign that to some variable, and again make a call on that variable so that inner function is called. And this discussion is done in the last class. So maybe if any recap is required, please go through that previous session. That gives you a very detailed idea. But this is the simple. Now, what is that we are doing in the next method? You can see here apply method. We are passing function as a parameter. You can see func. So what is this func means? This is nothing but a function as parameter. And another one is values. So just observe this, sir, and later on we'll talk about what function we are passing, what values we are passing. And in this, what we are doing is we are just iterating these values. When you are iterating values is some kind of collection, a data structure. Here you can see it is nothing but a list here. And on top of that list, what we are doing is we are iterating it. Sorry, friends. And then every time we iterate, one value from that list is passed to this function. This function, what it does is it calls this function, and then generally it is nothing but we are indirectly calling the inner function. This value is passed to this inner function, and we get the square, and that is written back. So this is what we are doing here. So what is that we are doing in this function? If you see here, in this function, we are declaring a function as parameter, which is nothing but to this, we pass inner function as a value. So how do you pass it? So if you look at the code, this is what it is doing. And this is clearly very simple one. We don't have any really difficult thing to understand. Where we pass two parameters, one function and one list here. And we are iterating list and passing this value each time when we get a value from list, and that is passed to the function. and it goes to the function and then implement that square and then that is written and this is appended to a implicit list. The whole result is written as a list here. So now if you see here, we are calling outer function. Outer function returns inner function that is assigned to this variable inner func. And we are creating one list and we are calling apply function. Just apply just performs an iteration and just pass value every time it iterates to func and funcs perform square and then returns that. That's what it is doing. And you can see to this apply function, we are passing this inner function as a parameter. And then this list, second thing, second parameter is list as a value. So these two are passed as parameters to this apply function. Now apply function simply iterate that list and pass each value to the function. And this function, what it does, it performs the square and returns that result back. And finally, all those results are accumulated into that implicit list. And finally, once this whole iteration is completed, whatever result we have here, that resultant list is written back. And that is assigned to this result. And we are printing here. Let's run this and see. And you can see this is the output 1, 4, 9, 16. So I believe we have proper square 1 square, 2 square, 3 square, 4 square. You got it right. 2 square is 4, 3 square is 9, 4 square is 16. That's what we got here after performing this apply function. Got it right. So this is the idea about what is that here we are passing a function as parameter and you can see that here. And which function we try to extract inner function that we are passing as a parameter here. So this gives you an idea that even we can declare function as parameter to another function. And generally such functions, technically we call them as higher order functions. There are much more advanced functions in our discussion. Generally, when you pass a function as parameter to another function, such functions technically we call them as higher order functions. Okay, we see that example even in today's session. But overall, this is the idea, friends. So we start from here, but and then we call apply function. To that apply, we call inner and list, and apply. You can see here it takes two parameters, and we mention function as parameter and values. You can see here, and this performs iteration and call the inner function. Okay, and from here, the inner function is called and the control goes every time loop iterates, control goes to the inner function, performs power, and finally return back that result back. And all those results are accumulated into this implicit list. There will be an implicit list created to store that results that are acquired after performing each iteration or accumulated after performing each iteration that is written to this apply function and we assign that to the result and we print it. That's what the how we execute all this step by step. Okay, and this is the result we get after performing this or the whole operation. So now this is the idea about passing function as a parameter to other function. And finally, such functions we call it as higher order functions. We have more examples on that. Now, coming back to the example of lambda. Lambdas are really very useful scenario. So in any real-time programming, there are many places where we see lambdas applying. And especially for data engineers, this is very much important because for you, we also use some PySpark, all that, right, friends? Even there, people use a lot of lambdas while they were using this kind of higher order functions like map function, filter function, reduce function. In all these functions, when you work with your PySpark coding, you definitely use a lot of lambda functions or anonymous functions in the code. So getting into the discussion, what is a lambda function? So if you ask me what is lambda, it is a simple one. It's not really difficult. So it doesn't anonymous function means something which don't have any name. And that is what anonymous function is. What we'll do is we'll do one thing. We'll just simply start taking an example so that it clearly make you simple to understand. Simply speaking, lambda functions are function without any name. And generally, lambdas are implemented in a single line. And this is very important. The exact purpose of lambda. When you create a lambda function, the use of lambda function is we can pass lambda functions as parameter to another function. Like when you have higher order functions, like just now we took an example, right? Even this is a higher order function where it takes function as parameter. So when you have such functions, what you can do, you can pass lambda functions as parameter to such higher order functions. And lambda functions don't return any, we don't need to add any return keyword. Okay. And then there are a few more points here as well. So sometimes, okay, we need a simple arithmetic function. This is simple. It's silly to write a method for it, but not to. Okay. If you want to just create something simple functions and we can implement those kind of simple functions with lambdas. You can see here with lambda, we create quick simple functions. And here no written statement is required. We don't need any written statements like how we implemented here in these regular functions or normal functions. For lambda, we don't need any written keyword. Even if you try it, it throws error. Okay. And when we use this, they are often used for short one-time quick operations, simply speaking. Okay. And if you want to pass function as a parameter, you can see here, particularly used when you need to pass function as an argument. And generally, we pass function as parameter to higher order functions like map, filter, and sorted. Okay, then these are very useful friends and definitely use a lot in data engineering, especially when you are working with PySpark, all those things. Okay, and there are certain facts here. Lambda functions can only be compromised of a single expression. Yeah, we just have a simple single syntax. So and you can see here no loops, no calling other methods, and lambda functions can take any number of variables. So these are important things we need to understand. Otherwise, if we do some 2 or 3 examples, you will get an overall idea how to implement lambda functions. Let me just show you. And again, going to the running notes here. This is simple syntax. What is that? Some variable name equal to, you can see here, lambda. For lambda function, it starts with the keyword lambda, and then it takes 2 parts. The first part is the parameter list. How many ever parameters you want, you can define that here. And the second part is the logic part. So expression can be a simple print statement or an arithmetic operation or any other operation. So here we pass expression. So this is simple syntax, lambda space parameters, like how we pass parameters here, these kind of parameters. Same thing, what we do, we pass it through this one. Here we define those parameters, colon followed by that expression logic you want to apply on that parameters that we pass after colon. And this is the syntax, friends. Let us do examples here so that you get a simple idea. Now, these are examples. Let's start with a very simple example. Function to add 10 numbers. Okay, let's try that. So let's create a simple Python file, lambda testing. Okay, and we can close these programs. And I'm sharing this code with you. You can test this for. This is a very simple example. Passing function as a parameter to. So let's do it. Otherwise, I'll share this and you can take this example. Next one, we can close all this. These are not needed. So the first scenario is this one, friends. What is that? Function to add 10 to a number. So you can take here. This is the simple scenario. So what do we do? Something like a result equal to, you can simply say lambda space and then parameter. How many parameters you want? Here, just to add increment something by 10, one parameter is enough, and then you can say x plus 10 here. Okay, what is this function doing? It is a very simple function which increments the value of x by 10. So that's what we are doing, to add 10 to a number. That's all right. So we pass something to x, that x is incremented by 10. Now, what do you do? Call this. How do you call lambda function? This doesn't have any name, right? Whatever the variable you are assigning, this variable itself acts as a function called to lambda, like how we discussed inner functions. If you remember, if we call outer function returns inner, and that is nothing but an object, function object, inner function object. And we had discussed in the last class as well. On top of inner, again, we should apply a method call. Whatever the object we have here, on that object, we should apply a method call, and then it calls that function, and we get the result. So what do we do right now? Simply speaking, so if you want something here, you can simply say something like some result of, so you can pass anything like, how much ever you want to pass, you pass here, something like 5. So now what do? You pass it to a print here, or otherwise assign to some variable, anything should be fine. So what do? Right click, run this now. Now you can see you got 15 here. If you don't want to print, you can do one thing. So you can assign to some variable, something like result 2 equal to. And finally, if you want, you can print that as well. That's up to you. But lambdas generally we directly call it, and we try to assign that somewhere wherever we want it to be included. Okay. So anything you can follow, if you can directly apply lambda, call lambda like this, or else you can assign that result whatever we get from lambda to some variable, and you can call that result variable. You can follow any of these two approaches, friends. Right click, run this now. Now we get the same output. We don't have big difference. And you don't have any written here. See here, friends. One thing you can see here. This syntax is so simple, and it is just expanded in a line. In C plus++, if you remember, we have inline functions. And this is something much more similar to that. Inline in sense function created in one line. Even lambdas have that. We just have one line here. And then you can see no return here. Even though you don't return, implicitly it is returning the value. And we don't need to explicitly declare any return keyword here. That returning happens automatically. And this is quick idea about lambda. See how simple this is. And this kind of simple code snippet, we directly pass it to this higher order functions. Mostly this map, filter, and reduce, they have a lot of usage. So to such functions, we always pass this lambda as a parameter. So this is the simple idea about one example. So how to add or increment the value of a value by 10 by using lambda. We can implement same thing with regular function, but if you implement regular function, it increases number of lines of code than what we do with the lambda. So this is the quick idea. Next one after that. So next, calculating sum of two numbers. See, generally we do one thing just for a quick comparison purpose. Suppose I want to find sum of two numbers. Let's do one thing. Let's copy this example, paste it here. Only the scenario, not suppose I want to implement this with a regular function. Then how do I do? Add some x comma y, and then what is that I should say? I should say return x plus y, and then again I have to call add of 1 comma 2, and then maybe I have to do print of add of all that. This is implementing sum of two numbers with a normal function, with a regular function, right? Right click, run this. Now you get 3 here. Clear about the result from the first example. See the output from the second example. See here, we got 3. Same thing, we can just do it in just single line. See here, friends. Even you can see print. You can see here LAMBDA. So x comma y colon x plus y. Okay. So now you run this now. Of course, we are calling this one. So we generally, better is assign this to some variable. That is the best thing. Okay. So what you can do is because we need to pass values as param, or otherwise I think we can do one thing. Let me just try this. Okay, print of. We can put this all in one bracket. On top of this, let me pass 1, 2 like this and see if this works for us. Okay. Now you can see this. This implicitly acting as a method call. On top of lambda, I am applying a function call. See here, friends. So what is this meaning? See, there are 2 scenarios. Let me split it one by one so that you get much more clear picture like what's happening at every step. So you see here, when I just tried implementing just lambda and passing this is test case. Let's take it as a test case 1 for lambda. Okay. Okay. And and then, so this anyhow, most of us know how to implement regular functions. But if it is lambda, I tried like this. When I run this, what's happening? I get function object. When you see this, the important thing you should remember is we should make a call on top of this object because just function object doesn't yield any results. If we should have some results, we should again make a call on top of this. That is important, friends. Okay. Next one, suppose if I want to do that call directly instead of doing all this process like creating lambda and then assigning to some variable and again calling, making a call on top of that variable. I don't want to do that. I want to do some instant call. Then this is let's take another test case. We can also try like this. What is this? So this is third way. We have seen one approach and this is another approach. Okay. So now if you see here, if I want to call it directly, what I can do, I can take this whole lambda on top of this, applying a call. And while making call, I should pass 2 parameters because this function lambda has 2 parameters. So here I am passing some 3 comma 4 or anything should be fine. 2 to 4 is fine. Close this. And this is how we make a call on anonymous functions, a direct call instead of assigning to any variable or anything. So we can even do this kind of direct calls as well, friends. Right? Click on this now. Now you can see here, right? 6, we got output as 6. So this is from test case 1, this object. And this is from test case 2. So where we applied a function call on top of lambda. So this is anonymous function anyhow, and we directly applied a call on top of that. So this is another idea, friends. Got it right? So copy this. Let me share this code base with you. So what do we do? Right click. These are all very useful scenarios because especially for data engineering, when you work with PySpark, you need this a lot of times. Okay, next after that is next example. Sorting list of tuples by the second element. We already tried these examples. Trust already while doing with dictionary, while working with tuples, I believe we tried this example. But anyhow, let's quickly do this. So how do you sort it? We are directly apply sorted. This is generic sort. Not we are not calling something from the list class, but we apply generic sort. We are passing parameter, just that whatever data that is there. Applying this lambda here, see here. Now you understand this easily because lambda is the syntax of lambda is just lambda keyword, parameter, and then expression what you want to do. So this is what we should do here. Okay. So now Let's take this example. So what do you do? Sorting list of tuples by second element. Even you can try by first element as well. And how do you do that? Let's do that with a simple example. Here you can take this other example. What do you do? You take data equal to, you take list of tuples. You can copy this list here. Okay. This is a very simple example to understand. So how do you sort this? You sort it simply by applying a sorted data equal to, you can simply say that sorted method, to that you pass data comma. You should apply one extra this thing. There is a parameter key. To that parameter, what is that you should do? You should apply your lambda. This X parameter name can be anything, X or Z or Y or anything. X colon. Number of parameters you want to pass to this, right? And then on top of that, what is that you want to do? You take which you should pass. See, every time this internally this sorted method calls, every time this list iterates. When list is iterated, one tuple is passed to this X parameter. Now you want to sort this tuple based on first parameter or second parameter. I want to sort on second parameter. Then if it is first, we should apply this X of 0 if we want first parameter, because every time you iterate, this tuple is passed to this parameter X. And if you want to sort by first parameter, you know, right? This tuple has indexing. This is having some 0th. This is in 0th index. This is in first index. If you pass 0, this tuple is sorted according to first parameter. Suppose you want to sort it by second parameter, then you have to pass 1 here. That's all, friends. So I finally print this. What is this? You can say simply, okay, sorted. You can say sorted data. Okay, and then you can simply say sorted data. Okay, friends, right click and run this. Now you can see here. And if you want this much more, you can see this time. This list of tuples are sorted according to the second value, 1, 2, 3. And if you want this in list format, how do you do this in list format? You can convert this whole thing into a list here, list of sorted data. Okay, right click and run this, friends. Got it, right? So this is the idea. Suppose if you want to sort it on first parameter, you can suggest take 0. Already they are sorted. So you can see 1, 2, 3. First parameter is already sorted. We don't have much to do. If they are unsorted, then we can apply this first parameter. But it's okay. Just giving you an idea. So if you run this, we get a sorted. So still it is giving us sorted data. Yeah. This time I think just a
Based on
minute.
first element, sir, it's sorted actually.
Yeah. Let's run this. Yeah, even I think this is fine, friends. We don't need to do conversion. I just got a little confused. I thought that this is internally returning a sorted object. Yeah, we don't need conversion, not needed. Just please ignore that, friends. We can directly use it. Now, the actual requirement is we see that the second element here in the list is not sorted. And maybe if you ask a question, if can we sort that second element instead of first element, then yes, the answer is yes. Simply what is that you should do? Just change the order of parameter here. Instead of 0th element, just try to apply sort on first parameter. Then the value in the first index, then you can see that list of tuples gets sorted according to the first parameter. Got it right, friends? You don't need conversion. I think I just misread that output, friends. So I thought it might threatening. a sorted object. No, not that. This is just description I added to this print statement. So no need of conversion. That is an unnecessary operation. So please ignore that. And this is how you have to create it. Finally, this is an idea about this scenario. Right next after that, few more examples. This we had already discussed. So when did we discuss? We discussed this in yesterday's, I mean, in the previous class example. But we applied a regular function instead of lambda functions. If you remember, see here, friends, let me just show you function returning multiple parameters. So not this one, inner functions. Yeah, you can see here now. This is an inner function where we try to create multiple operations. Sorry, you can see here. This is an outer function where we created multiple operations with simple inner functions. And here instead of we are using regular functions, you can say diff, add. These are all regular. Same thing we can replace with lambda. So same thing. Suppose if you see this example here, wherever we are using normal functions or wherever we are using regular functions, we can replace this with lambdas, and we can again return the result back in the similar scenario. And if you are replacing lambda, you can avoid many things here. What is that? So you can directly apply return, and in that return you can try like this. I think this guy is also okay for maybe this thing we can try it, but what we can do, we can simply try like this. What is it? Some we can directly take here instead of method called lambda of x comma y colon x plus y. Let's try this. Okay. And on top of that, what you can do, you can make a implicit call. This is direct way of calling. Just pass one command to here. Just we are replacing same program with the lambda function. Now, similarly, what you can do, friends, you can apply diff as well. Copy this and paste it here. What you can do, call this and just say minus here. We already tested just few minutes back, friends, how this works. Okay, don't get confused. If you want here at this level, you can just assign these results to some variable and again make a call on top of lambda object. So that is one thing. I'm making it much more straightforward approach. So just creating lambda, calling lambda then and there itself instead of making it a two-step process. Okay, friends. So if you want, you can break down this into two steps, how we did in the first example. Okay. And here you can simply say x into y. Okay. And finally, just call this return operation. And when you do return, I believe you don't need to, yeah. So this automatically returns a dictionary of what? A dictionary of these values. Now add and key value pairs here. So add and diff and prod here, and you can see. So all that program, we just simplified this with a simple lambda here. We replaced regular functions with regular functions with lambdas or anonymous, and we made it much more easier here. So right click, run this now. Let's see what happens. See, perfect. So what is the difference here in the? So if you look at this scenario, I'm just taking it. So in the previous example, what is that? We have all this one. Okay, let me just add the lambda code here. This is a lambda scenario. If you look at, we just replaced all these regular functions with lambdas. Okay, and we made this process much more simpler than what we are doing here. If you look at this example and this example, the one which we are implementing with lambda, maybe you just make this as arithmetic operations 2 and 2 result 2 and result 2, right? Then we don't have any confusion here. This is fine. Now this is much more straightforward. When we have this simple and quick kind of implementations, quick methods, simple methods. such functions or methods, you can just replace with lambdas. And this is, if you look at this, this is much more sweet and much more simple and much more easier here, right? When you run this, both will produce same output. Just print this. Which one, Fred, sir? You need to print result as well. Just do one thing. Print result. Right click, run this now. See, same output. Only difference is in the first approach, we are implementing this inner functions as regular functions. In the second approach, we are implementing inner functions as lambda. And this is more like just doing a simple operation, like a simple logic, applying a logic. This looks like we are doing some kind of method or something like that. So, and this is much straightforward. Second approach um, is a straightforward one. That's all, friends. This is the idea about one more scenario, right? And that is this example. Got it right. Next after that. So I took few more examples because keeping the importance of lambda in mind. Again, we go to higher order now. So that will totally give you a bigger picture about lambda. So now, so this example, this anyhow we just discussed. We can ignore this now for now. So sorting strings by their lengths. You can see here that we have strings here, list of strings. If you want to sort them, you can just now we applied the sorted method. You can take pass that whatever data structure we have here that as a value to sorted method and apply that parameter key to that assign this sorted method. Here we can pass even a regular method as well. So instead of regular, we are passing this lambda. And what is that we are doing here? We are just sorting this whole list based on the length of this strings in the list. So this is the example. So this anyhow we already discussed such scenario. We can skip it for now, friends. Okay. So now this is another scenario I would like to discuss quickly before we jump to the higher order functions. What is this? This is an example where we are trying to sort population, sort cities by population. Okay, we have cities and population. We are sorting by population here. You can see here you have a dictionary here. This is how generally we get data when you are working in real time, friends. So we have a dictionary, we have cities here, and then their population. Now we want to sort it based on population, not cities. Then what do? Just apply sorted method. Okay. And to that, just if it is a dictionary, what is that? We need both key and value pairs, right? So then in such cases, apply items. And on top of that, again, this is same. See here. If you apply item of one, so this sorting is done based on second parameter. If you apply item of zero, this sorting of the whole dictionary is done based on first parameter. Okay, we'll try this. Let's take this simple thing. Other things we try it. We'll test it and see. Copy this. So now what do you do? So here cities. Maybe otherwise you do one thing. Yeah, let it be here. No problem. And now what is that we want to sort this? This is not really difficult. Cities underscore something like you can say sorted equal to, you can call sorted method and then to this sorted, what is that you can do? You can copy this dictionary. If you directly pass dictionary, what happens is it just uses these keys. If you want to get both key and value pairs, both this whole pair, then apply dot items. Okay, comma, you take key parameter. That key helps you to apply sorting logic. That you can write a customized sorting logic or you can pass lambda directly here. Customized can be done with regular functions like this. Okay, or like this, anything. Okay, but lambda is much more straightforward approach. By now you should get that idea, friends. So what do? Lambda space lm, yeah, xr item. You can say anything is fine. X colon. So x of you want to sort it by name or by population. If you want to sort it by name, pass 0. Because this is a tuple. Implicitly, when you apply items, this key value pair gets converted to tuple. And this is 0th index, this is first index in tuple. So by which element you want to sort, that you have to pass here. So suppose you want to pass sort by population. The idea is to sort by population. Let's try that first, okay? Then we sort it by second one. By now this gives you, you might have got a deeper idea about like how we can do sorting on not just only on dictionary, but on list or tuple or anything, friends. Okay. So finally what you do, we just print city sorted. So observe the output for last one. Just see the last output, friends. That is from this one. Okay, right click, run this, and this is what the output is. You got it right, friends? So that's the idea. See here. Finally, you can see these cities are sorted according to the population. Just check that. That gives you a very clear picture. Suppose if you think that these values are too big, just give small values. Just modify these values as a smaller ones and just check the results. Suppose you want to sort it by first value. So by name, city names, just change that parameter here. So now I am trying to sort based on first or otherwise the parameter is in the 0th index. So x of 0, right click, run this now. This time you can see these cities are sorted according to the city names. You can see here first we have C, H, L, N, N. So definitely you can see a change in the order of that key value pairs. And this is how we can apply what, friends? We can apply sorting of dictionaries. Of course, that dictionary implicitly is converted to tuples. On top of the tuples, this sorting is applied. And if you want to convert this back to dictionary, what is that you should do? You should apply a conversion here, some dict of. So, so when you say dict of, then finally you get expected result in dictionary format. See here. Now output stays same, but earlier it was list of tuples. Now it is a pure dictionary. For that, once after do all this sorting, we do all this sorting, we have to convert back that result to dictionary. So this is the idea, friends. This is how we can apply sorting on all this population or whatever you want. And point is simple. Everywhere you cannot ignore the importance of lambda functions. See how useful these are, how simple and how quick to apply. Right? This is the idea, friends. Next after that is we're done with this lambda. We will we let's make it closing call for lambda now. And by I think we try to have covered many scenarios here, how lambda works, everything. Let's jump to the next topic. So this anyhow we have already covered whatever examples we have here, you know, we have included here, friends. Okay. So now you can try this simple example, not a problem. What is that? So this just validating what is it, friends? Whether greatest of two numbers here. This is a simple scenario, not a difficult one. So few more examples. Already we have gone through this. So you can try this again. Okay, next after that is higher order functions. Yes, this is important. This is really very important even in your data engineering, and especially when you are working on PySpark, because PySpark uses lot of higher order functions. When you try to do that, apply anything, this thing, friends. Okay. So what is a higher order function here? It is a simple one. Higher order means so the map or reduce or filter or chip, whatever it is. So it is a function that takes another function as a parameter. And we have already created few examples, not a direct higher order, a customized one means something which we implemented directly. Okay, somewhere passing function as parameter. If you look that example, not this one. Yeah, function parameter. See this. So this is a higher order function. Ideally, this is a higher order function. Same thing, we have some built-in higher order functions which are really very important for us. What is it? This map, this reduce, this filter, all that, this zip, all that. Okay, we'll just quickly go through one by one here. Map function. What is a map function? This is syntax of map. And this is very interesting for us. Okay, friends. Just a minute, friends. Give me a minute. Sorry. There is something in the middle. Yeah, let's continue. Map function. What is this here? So these are all higher order functions and these are built-in functions. Okay. And generally this takes a function or lambda as a parameter. We can pass either a regular function as parameter to map or lambda is much more recommended than regular functions. Whatever you think is best fit, you can pass that to the map. All recommended is lambda generally because this lambdas are expanded in a line so that that best fits to this these higher order functions. And it takes two parameters actually. If you talk about map takes, see the syntax here. If you take at least it needs two parameters. One or more iterables like list, tuples, or sets. One parameter is always a function. That function can be a regular function or lambda. That is one thing. And the second parameter is it has one or more iterables, which is nothing but lists or tuple or sets. You can see the syntax here in the map. So map function is first parameter and iterables that can be one or more. So it's up to you how many you should apply. That depends on your logic and requirement. So what map does here? It is a very simple. These are all again a kind of doing iteration and doing applying some logic. That's what these higher order functions do. So what it does, map function applies given function, whatever function you are passing to map. Map is a function. Again, inside that we have a function as parameter. What it does is it applies the given function, means something as a parameter to each item in the iterables. This is where you tried here, right? If you see this example, we passed as a function as parameter to this customized function. So what is happening here? What apply function is doing? It is iterating the list here. Same thing is applied even in map, friends. We just created a customized example. Same thing, a similar scenario is applied with the map. If you look at here, this example, we just passed a raw function here, and then we passed a list of values. What is happening? Every time loop iterates one value we get here. That is passed to this func. And func is internally calling this inner function. And that increments x by 2. And that result is written back. And all those results are accumulated. Even map is doing a similar operation. So here if you look at it, what it does, it applies that whatever iterables here, it iterates each value in that iterable and that is passed to this function. That is what the meaning of this. What is that? Map function applies the given function to each item in the iterables and returns an iterator that yields the results one by one. So that's what we are discussing since long time. So what is that? So anywhere what happens even here also, once we apply function, we get some square. That square is written and all that are accumulated in the implicit list. And finally, once this whole operation is completed, when we return this list, we get list of those results. And that is what meaning of this here, what this statement is saying. Sorry, friends. So once we apply iterable, we iterate each item in this iterable and that is passed to the function. And then that function will return some result. All that returns. Finally, this map returns an iterator that yields, means all that results what we got applying function each time an iterator is executed. So all that results are yielded into this iterator object written by map. And every time we apply iterator, one iterator, I mean loop is iterated for one time. We get one value. And all those results are yielded one by one. And finally that gives you an iterator object. So this is the idea about the execution flow. We'll see that with example. I'm just trying to explain how the behavior of map. Not only map, almost all these higher order functions work with in the same way. The difference is there will be a slight change the way we apply logic, that's all. But the execution flow is almost similar in map or reduce or filter or all these higher order functions. And second thing, it's very convenient to apply same operation to the multiple elements in a collection. Yeah, because you have an iterator and this iterable object and it has many values. And same value you can pass to this function, which yields a similar result for all those values which we are having in this iterable object. Okay. And finally, you can optionally provide more iterables as parameters to map. Yeah, if you want, you can add multiple iterable objects. And it replaces tuples in the result. So that result thing we have to see. We'll see in the example. Okay. And finally, what map does? Map returns an iterator which can be cached to a list. What are all this? Instead of discussing this theory here, let's jump into the example that gives you more idea of it. So what we do is, let's do one thing. So here, just take one more new file and say it as a, this is really very useful, friends. Higher order functions demo. Apply. Take one simple function. Before we apply lambda, let's break down this program into two steps. Take a regular function and apply this, and take a lambda and apply this. Applying lambda is much more straightforward, friends. Okay. So what you do here is, we'll take simple example of map function. You can see, just take this. So we do one thing, we take a list. Okay. So applying map function here. So take a small list here, something like list one equal to, or list of integers 1, 2, 3, 4, 5, something like this. You can take any values, it's up to you. Just for testing purpose, I'm just sharing one list here. Next after that is a next one. Define this function, def some, okay, add you can say, and then pass a parameter value to that, and then so requirement is this function increments every value. Okay, I'm just writing here by 100. You can change that logic. Okay, I'm just giving you a quick idea. This is this introduction example, right? So that once you understand this, you can change that logic and do whatever you think the logic you want to apply in that function. Okay, so now what is that I should do? When I pass a value to this function, each time I should increment that by 100. It's a very simple one. Return, you can simply say direct return value plus 100. So we can break down this into two steps if you want. What is that? You can say some result equal to, okay, value plus 100. You can say, then you can say return result. So this is a two-step process, but at development level, we just merge this into one step. So whatever we are doing right now. Okay, this is done. So we have an input, which is a list, and we have a function to which we should pass this elements. This list has value to this function. But we don't pass direct list. We iterate this list and just try to pass each value at a time. One value at a time to this function. Okay, fine. To do all this, so calling method, calling this function or method, and iterating list, all this, if you want to do all this in one shot, Best thing is apply higher order function. What do you do right now? You take map example, some map you can see here, map of, then pass that function as parameter. What is that? Add function, comma to this map. What is that you should do? You pass that list as parameter. Okay. Then if you want, you can directly assign this to some result. What do you do? Some resultant output. So result data equal to. And finally print that result data. Okay. Right click, run this. Now you got a map object here. You don't worry here, friends. By looking this output, you don't need to worry here. So we got actually whatever we are expecting. But what this map does, this is what the last point here saying. I want to show you that map returns an iterator which can be cast to list. Okay. If you don't cast to list, what happens? This is the what we get. We get a map object. And this is a kind of generator. And in implicitly all that values are wrapped into this object. Now, what is that you should do? You should iterate it. One approach is simply now you for some value in okay, value in results data, print val. One thing you should do is iterate this map object because this map implicitly is a kind of generator or an iterator object. Means implicitly you have values that you got everything is working. What's happening here when you apply map function? This map, what it does is it iterates value by value. So in this list, and each time this list iterates, one value is passed to add method. And once this value is passed, a method is applied. A method call is applied on this value. Add method call is applied on the value that is passed from list to this add. When you apply add method on value, then this method is called and the value is incremented by 100 and that whatever incremented value is written back to the map back again. Map again yields that result and stores into some temporary data structure, which is it usually it is a generator object implicitly or iterable object if it is iterable object. It yields all those results into some data structure and finally that is written back as a map object. And one approach is if you want to see that results, just iterate it step by iterate it using this our regular iterator for iterate. Right click and see the output. See here. You can see we just passed one two. We have list has 1, 2, 3, 4, 5. And we are just passing 1, 2, 3, 4, 5. And that we are getting it as 101, 102, 103, 104, 105. So our results are different now. See, totally we have a transformation. See, this is more or less doing a kind of data transformation here. How this transformation is happening in data engineering terminologies, this is we're transforming data. So how this transformation is happening every time loop iterates. So on each value, we are applying incrementing that value by 100. And this is the transformation we are doing on that original values. It's a kind of transformation operation. And that is simply done with map. You put a debugger here, right click. Now let's see how this works. So the execution flow is, so this list we pass as a, we take two parameters to map and list every time list iterates, you know, right? We have 5 values in the list. This iterates for 5 times. Then this add function is called for 5 times. All that thing iterating and passing values to add, everything is done by the map itself, friends. So let's debug it. Let's do debugging and see, right click and just do the debug. And you get a much more bigger picture how this works here, okay? So now it's still in the progress stage. Yeah, now you can see debugger is there. Now let's try going line by line. This is a method call, right? Then what do you do? Do one thing, get into function, step into function. So even though if I say step into, it is directly going to the next one. It's not jumping to this. So I'm just trying to see that. Okay, right click again. Let's debug. Okay. So finally, in one shot, it is trying to get everything. So I'm just trying to check. Okay, do one thing, then put a debugger here as well. Let's run this now. Okay, let's try step over. Okay, so this is applied. You can see now. This is interesting. So finally, after getting this object on top of that, implicitly, what is that? This is calling this function. Now you can see first time value one is passed, and let's see this step by step. You can see here that is incremented to 101, and that is returned back. Again, next step. See this. Okay. Next, after that, value two is called. Every time this iterates, list is iterating, one value from list is extracted and passed it as a parameter to add. You can see that the execution flow in the iterator object. We are calling iterator object. That iterator object has internally the setup to implement that thing. Okay. So now what do you do? So next again, now two is passed. See this now one by one, and it increments that 2 by 100, and it is 1 or 2, and it returns that. Again, see this third thing that is printed. Of course, it is fine. Next again, uh, you can see that add is called back again, because that map object implicitly has two things, that function and listed. And when we pass that as parameter to this one iterator, so you can see the how the implicit operation is being carried out. Okay. So 3 is passed, incremented, we get 103, and that is written back again. So that is extracted and printed. Okay, and finally again one more, again increments by 100, returns back, and that is extracted and printed. And finally one more, 5 is passed, increments by 100, written back, that is extracted and printed. This is the execution flow. You can see all this is implicitly happening by who is doing all that? Map is doing all that. Actually, we should do all that. That thing is done by the map here, map function. And these are rigorously used in the data engineering scenarios, especially in PySpark. So this is overall idea about map function with just what we are using a regular function. Now, what is that? You can make it much more simpler with lambda. See, instead of all this, of course. So you don't need to do this. What is that? If you want to say output, so the here our output is what, friends? If you run this, you can see we get a map object. If you don't want that, you can apply simply conversion. Convert this to list here, that map to list. This time, of course, if you want, you can iterate it. But finally, we can get a viewable output. Even if it is list, we have to do iteration, right? So we can keep this as is. But this time for a change, a result data is not a map object, but it would be a list here, a properly converted list. Now right click, run this and see the output. See here, you can see a list, and no more you are not seeing anything, a wrapped object like map object. You got it right, friends? So this is what you can do. That's what the meaning of this last statement. Map returns an iterator object which can be cached to list. That's what we did now. You can see this casting when I applied. You can see a total change in that output. You got it right, friends? Huh? You can see a total different output. Earlier we are seeing map object, this time we are seeing a list object, and iteration is common for both, of course, you know very well. By seeing these many, we have completed so many sessions so far. And for we are seeing how important for is as well, okay? Same thing, we can rewrite this code with a simple lambda. Now see how simple when you just take this, copy this again, okay? Replacing with lambda. Okay, placed it here. And then what is that you should do? Instead of add, you can choose lambda lambda. Sorry, friends, just a minute. Space x colon some x plus 100. You can change that operation this thing. Complexity of lambda thing, you can increase it, that's okay. But here, taking a simple example gives us a clear idea. So this whole process, you can see this whole process, we just did this in 2 lines. You can see here, if you want, you can take another list as well. Instead of list one, take list two. You take here some 101, some 100, 101. Otherwise, I'll take like this 10, 11, okay, 12, 13, and 14. Now, so what we are doing here, this whole process just replacing with one line here. See, okay. Now, if you want, you can convert that to list, or you can keep that as map object. But converting to list is much recommended operation. So finally, what you need to do, just print result data, right click and run this. We get two outputs. Result data two, of course. Here also result data two. Run this now. Now you can see the second output is this. So, and here we are passing list one. That's why we are getting same result here. Might be, you might be thinking we should get 110, 111 or something like that. Let's see this. Now you can see that the output changed. So see, when you replace lambda, the total outlook completely changed here, friends. See, the way we see this code is little different. The way we look at this is totally different. See how simple this looks like. That's what the power of lambda is. That quick functions what we create here. Got it right, friends? We'll stop here. Tomorrow we continue with the remaining higher order functions, reduce, filter, and zip, all that. Maybe if possible, I'll add one or two more examples, more scenarios for map all this. Okay, little more complex examples. So that's it for today, friends. Interesting. So these are really useful scenarios.